Hello, my name is Alan Taylor, and I'll be speaking on my topic on fungicide seed treatments for hemp to control damping off. Introduce people from my laboratory in Massey, Dr. Amar Khani and Dr. Hillary Mayton, as well as other people from Cornell are contributing to this. I also have as a project in cooperation with Burton Johnson at North Dakota, and will show some of his data as well. First, let's look as an overview of post-harvest aspects. And this isn't just for hemp, this includes really all crops. You start off with harvesting the seed from the mother plants in the field or greenhouse, going through different cleaning procedures, different methods to upgrade the quality of the seed before they go into storage. So this is a process that field crops, vegetable, and all crop seeds will follow. Now in the treatment phase, we look at a number of different functional treatments, or as we call seed enhancements, including priming, coating technologies, film coating. So we're going to be using film coating, and you'll see this as I go along, what our methods are for the film coating application as a low volume application to the seed surface. The focus of this project is on plant protection, in particular from plant diseases that cause damping off. So we're looking at fungicides, both chemical fungicides and biopesticides. So here we're looking at the overview of seed treatment and coating technologies. There are dry application from powders used like for rhizobia and other biologicals. However, the main unit that's used is the rotary coater. This is used both in our laboratory that I'll show, but also used on a commercial scale as well. We're applying the liquid materials, which include the film coating polymer, also can include fillers or powders. However, we're not using those materials in this with the fillers and powders, just liquid application. There's also a drum coater for pelleting seeds. This is from a review article that we published last year on seed coating technologies. This is our unit called a Rotary Pancoder. This is a laboratory scale unit that we've used for many years and is a very robust unit for laboratory and small scale work. It's called an R6 for a rotary 6-inch, or you could say is 15 centimeters in diameter. On the right, you can see rather than using a spraying nozzle, there is an atomization disc. And the atomization disc would take the liquid hit that and disperse into the seeds as they're mixing. So it's a very rapid process used for treating seeds. We even have a YouTube on this if you'd like to enjoy a short video on how to do film coating of seed. Now let's look at this is hemp seed, the non-treated seed. You can see the kind of a waxy coating by looking at the light reflectance. When we started this project a few years ago on seed treatments and seed coatings, many of the polymers simply do not adhere well. You can see that they're treated, but there's a rather poor uniformity of application from seed to seed and over the seed surface. Working with the seed companies, we now have other materials that we're using to get a much better uniform application over the seed surface, so we know that the plant protectant is being applied uniformly to the seed. We now move into the area of the biologicals, and there are a number of biologicals products from biofertilizers, biostimulants, biological control products. We are going to be focusing on the biological control products as we're controlling a pest with the biopesticides. So now we can kind of zoom in on that particular section. So we'll be using really kind of materials from two of these groups, the biochemical materials and the microbials. In the biochemicals, using organic copper material, also phosphites. On the microbials, we have bacillus and trichoderma as beneficial bacteria and fungi. So we have basically a cadre of different microbials that can be used and are formulated by the companies that we've obtained for this project. Now we've color coded the treatments. The black up at the top is the non-treated check. All those in green, you have the trade name and then what the active ingredient is or the active component is. You can see trichoderma, bacillus, a number of well-known biological control agents there, and the dosage rate. As we've done this work, one of the first steps we do is to treat the seeds and just do a standard germination test. If the materials are phytotoxic, then we need to change the rate so they're not in themselves harmful to the germination of the seed. So these rates would be considered as a safe application rate, as none of the companies had experience with hemp with their particular treatments. The next group, the safeguard and prudent, are the biochemical treatments, the organic copper and the phosphites. The last group are the chemical seed treatments. You see the Apron XL Maxim. If you've worked at all with chemical seed treatments, you're very aware that these are widely used on field crops, vegetable crops, and other seeds, as well as chemical fungicide seed treatments. We're looking at these at different rates, and the last treatment in combination with thiabendazole. Now, the first thing that we do is also to give an idea of the potential efficacy of these treatments. So we developed this bioassay in the laboratory. We're using a standard roll towel. That's what the brown paper is in the back. And then applying a builder sand mixture with a natural pathogen infested soil. In fact, it's the pathogen infested soil is from the same field site that you'll be seeing the data in just a moment. Hemp seeds germinate very rapidly. So just 4 days after planting, you can see the seedling roots and shoots. After 7 days, now we're seeing the post-emergence attacking by the pathogens. And then by 10 days, pretty much nothing is left for the non-treated. So we have a pretty stringent test to evaluate efficacy of these treatments. Let's go to our field testing. Again, Burton Johnson is a cooperator on this project from 2020. So we have his test site at North Dakota State, our work at Cornell. We also had cooperators from Virginia Tech. I'm not going to be showing their data today. So let's visualize the data that we have at this point. We have the control, which is the black line, the black bar, but then all the green bars, which are the biologicals. None of the biologicals did any better than the control. The safeguard and the prudent, the organic copper and the phosphite doing well in this study, and comparable to our best chemical seed treatment. Also, we have the study from Burton. Similar trends for the biologicals. No significant improvement compared to the non-treated check with any of the biologicals. The organic copper looking good here, but our best treatments overall are the chemical seed treatments. So by doing these studies, we had 2 test sites at each location. And then also having Virginia Tech, so we have a total of 6 field sites to draw our information from. So to summarize, our biochemical seed treatments, in particular the safeguard, had good efficacy in the field testing, kind of on average. Our chemical seed treatments, the Apron XL Maxim, also had very good efficacy. However, we ran into the situation where Syngenta, the manufacturer of these materials, was very enthusiastic about this project just 2 to 3 years ago now are no longer interested in supporting labels on hemp. So we're kind of did the work, showed the efficacy. However, they'll never really see the light of day unless there's a change in their corporate structure as far as being interested in this. And as repeated across the board, we've not seen any of the biologicals that we've tested were effective to control damping off. So what we're working on this year is kind of continuing, but to focus on, rather than the industrial hemp direct seeded in the field, now we're looking at CBD hemp, which would be a high value crop for the CBD production in containerized plants for transplant production. And if the soilless media, the greenhouse media had pythium, had disease pressure in it. When really now just taking those 12 treatments, now we're just focused down to a few of the organic coppers and the phosphite. So let's return to our soil bioassay that I showed you earlier after 10 days. The upper treatment is the organic copper, overall looking very good under a high disease pressure compared to the non-treated control below. Also, there's been a name change. The Safeguard, which is a material from Germain's, is now called ProBio Ultim. So same material, just under a different trade name. And that is, again, what we are working on for this year's project. I want to thank the people. I already mentioned Mossy and Hillary at the very beginning, but also Michael Luce was very helpful in doing this. Gary Bergstrom is my cooperating plant pathologist, Burton Johnson, company registrants, and also the sponsors of the